Hello and welcome back. In today's session, we will look at some hands-on on how we can containerize our application. And then we will also look at how we can build our custom container images. So we will look at Dockerfile examples, and then we will convert the Dockerfile into custom images. Once again, before I start off with the session, please don't forget to hit that subscribe button. So here I have my EC2 instance, and this is where we will be having our Docker file, and we will be creating our images. So we will use this EC2 instance to build our container images. Now, as discussed in the previous session, container images are defined in files called Dockerfile. So you will need to basically write those instructions in a file, which is what we call it as a Docker files, and then we use these instructions to build our container images. So whenever we are talking about creating our custom images, we need to define a way, right? We need a way to define those instructions to build our custom images. And this is where we make use of your Docker file to define those instructions. And then we convert those instructions into a container image. So here I have three Docker files. So we will be looking at each of them one by one. So we'll first look at the first one, which is the version 1. So here I have an example of this Docker file, which will help us to set up Tomcat and then deploy var package on to that Tomcat. So basically we are setting up a Tomcat application and then running the Tomcat application. Now, as you can see in this Docker file, we are having multiple syntaxes. So we have the from instruction where we're defining Ubuntu as our base image. We'll have the run instructions where we're installing some packages. We are downloading some files. We have the copy instruction to copy the source code, and then a few more instructions. Now, by using all of these commands, we will be able to create our customized container image. All right. So you can give these instructions. So there are different instructions, right? So by using these instructions, we can give the instructions and then convert these instructions into a customized container image. So we have the from instruction here, which tells us the file system that we want to use, and here we are making use of the Ubuntu file system. So because we're using the Ubuntu, we'll make use of the apt-get package manager, and then we will be installing some binaries that is available on the Ubuntu system. So you can see here we are updating the machine. We're installing Java, wget, Maven, which will be used to build our package. We are creating a directory, user local Tomcat. Then we are downloading our Tomcat. We are unzipping our Tomcat. We are copying everything from Tomcat and pushing it to this path which we are creating over here. Then we are copying our source code, which is there on the local machine. We are copying that to the temp folder. We are setting our working directory, and then we are basically creating our package, right? So let me change this to package because we just need that. And then we are copying our var package to the Tomcat folder. We're exposing the port number, and then finally we are starting our Tomcat service. Okay, so this is basically what we are doing here. Now I just have to make a small change. So this app code, so let me go back here. So you can see I have the source and pom.xml file. So let me create this app code folder, and let me copy this to app code, and also this to app code. I have to use -r because the folder has files inside it, so we want to do it recursively. So now the basically I'm copying everything from this to the temp, and then we are building it. So now that we have our instructions ready, we will need to convert these instructions that we have in this Docker file into a container image. And for that, we will need a container image builder, which will help us to build this Docker file into a container image. Now, some of the container runtimes include image builder and also a container runtime. So one example is your Docker engine. So the Docker Engine container runtime can be used to build our instructions into a container image. Okay. Now, what that means is we can use the command line of your Docker Engine container to build our image. So let's go back, and the command for uh, building our image will be docker build, and then we'll use -t, which is to give a name to your image. So let's call it as version 1, and then we will give the file where our docker file is the instructions is available, and then we will need to give the path um, where to find this instructions file. So I'm giving dot because I'm telling docker to look for this particular file in my current path. Okay, so if it's available in a different path, then you can give the absolute path to that file. So now, just by passing in these commands, we can convert the instructions that we have in this Docker file into a container image. So let's run this command. So, so we have in total, we have 14 instructions. So it will start executing the instructions one by one. Now, if you're running these instructions for the first time, then it may take some time for all these instructions to execute, because it has to go through each and every line in the Docker file sequentially. Now, if you build this image again, then it will be much faster, because now the instructions will be available as cached layers, and then we can reuse them to build the container image. So let's wait for this to complete. So based on the instructions that you define in your Docker file, so you can see here it is using Ubuntu as my base image, then updating. So this is all the update step. Then it is installing some packages for us. So all this is basically those output. Let's go. Yeah, I mean, this is continuing, so we will give it some time to complete. Waiting for this to complete. So yeah, I mean, it's at step 10. So let's wait for that to complete. This is where it is building our var package for us. Okay, so finally it completed. So as discussed in the previous session, so every time we add a new line in the Docker file, we are basically creating a new layer, right? So this is one layer, and here you can see that's the ID. Then this will be another layer, this will be another layer, and then so on. So based on the number of lines you have in the Docker file, that many layers will be created for us. So there will be a new container image layer. So the more lines you have in your Docker file, you will get more number of container image layers. Now that our image is built, let's run this docker images command, which will list the images for us. And here you can see we have created our image, and this is the size. So it's quite a big container image for us, right? So it's 847 MB, right? So that's a very big container image that we have created. How do we optimize this container image and reduce the size of this image? Okay, so here I have another docker file, right? And the instructions may look very similar, but there are some major differences in this second version of the docker file. The first thing you will see is the from layer. So in the first Docker file, I was using Ubuntu as my base image, but in the second Docker file, I'm using Maven as my base image. So again, depends on the use case. If you don't need all the binaries and dependencies, you can make use of Maven as your base image. So we are no longer starting with Ubuntu as our base image. Rather, we are starting with Maven as our base image. So now Why we are doing this is to simply take the advantage of an existing container image that contains all the dependencies. So with this, I don't have to install Maven because this base image will already contain all the dependencies required to build our image, and then copy that image if required. All those things can be done. All right. So this will help us to optimize our image. So by using this existing container image, I do not have to worry about making sure I have installed the latest version of the latest patch. I can just use this existing Maven image and trust that the open source community is keeping this base image maintained. So you can see here we are using that, and then we are installing some packages. We are creating our directory, we are downloading our Tomcat, we are copying the source code, and then here we are creating our package, and we are copying it to the user local Tomcat. And also you will see here I'm setting my user instruction. All right. Now, another major difference that you will see here is how I have collapsed my run instructions. Now, in the first version of the Docker file, I had a run instruction. So basically, all of these instructions were in a single run instruction. All right. So I had like X number of run instructions. So basically, each command was in its own respective run instruction. And in version 2, we have only few run instructions. So basically we have collapsed. So you can see here I have one, two, three instructions basically. Okay. Save that. Yeah, so I'm basically collapsed the run instruction. So here also you can see this is one instruction, this is the another instruction. Here also I have collapsed the run instruction. Okay, so and just like that we have combined all these run layers into a single layer, which is more efficient and helps us to reduce the size of the resulting container image. So and then next we have defined our user instruction here, and this is the user that the program inside the container will run it. And we want to run this with an unprivileged user. So all the instructions until here will be executed as a root user, and if you want to execute any instructions as a non-root user, we can set that user using this user instruction. Now in this case I'm using nobody as my user, and this is what will be used. Okay, now this basically means that if there was a container escape, and if my container was able to escape the isolation boundaries of the namespace and control groups, then we will not have a privileged user on the server. It will be an unprivileged user called nobody. So we have put in some best practices in version 2 of the container image. So basically using the right base image, collapsing the run instructions, setting the unprivileged user. So these are some of the best practices. Now we will build this image again. So let's call this as version 2, and the file would be version 2. So this will go ahead and build the second version of the image for us. And basically we are optimizing the container image. So this will uh, the size of this image will be much lesser compared to the first version of the image. So by combining all of these run instructions into a single line, we are actually able to reduce the size of your container image. Okay, so let's wait for this to complete. Okay, so this is done, and let's list our images. And you can see here, so this is the version 1 of the image, which was 847 MB in size, and this is the second version of the image, which is 630 MB. So this is a more optimized version of the image we have created, and this is because we are using Maven as our base image. We have collapsed our run instructions, so we are basically having single layers of the run instructions. So now we have a much more optimized version of the container image. Now The advantage of this is that it will help us to reduce the bandwidth required to run the container using this image, as well as reduce the storage requirements. Now, because it is only 630 MB, the storage requirements is also reduced, and also it will also reduce the time taken to start the container. So the container start time can also depend on the size of the image. So now, because this is smaller in size, the container start will be much faster. Now we will go one step further, and this is going to be the final step. And what we will do here is we will be using something known as a multi-stage build. So that's going to be my third version of the image. So we are making use of a multi-stage build here. Now we will make use of multi-stage build where we are actually going to use a build stage and a deploy stage. Okay, so this is where we will be creating our package, and this is where we will be deploying our package. This can be really useful when you have to install dependencies like your compilers, but you do not need those dependencies in the final container image, but you need them when you are compiling or installing the application. Like for example, let's say Maven. So I need the Maven only to create the package. I don't need Maven in my final version of the container image. In the final version of the container image, I just need the package, right? So that's where we can make use of your multi-stage build to optimize your Docker images and reduce the size of your container images. So once we have compiled the application or installed the dependencies or built whatever we need to build, we can simply copy those artifacts from the build stage into the final running container image. And the running container image is now nice and lightweight. It does not need the compilers, it does not need Maven. We don't need all those things, right? So we're not going to do any of this compiling in the production environment. We just need the package to be available in the production, right? So we do not need to transport it to the final version of the container image. So if we had to transport this, then we would have, we will have an increased size in the container image, and we would have to increase the risk of somebody using bad utilities in the production environment. So the build step here has a from instruction, and then we are using Maven as our base image. We are copying our application code, and then we are building the package over here. And then we have second stage where we are using Tomcat as our base image. We are setting our working directory, and then we are copying from the build stage, which is here. We are copying the package, right? And we are copying it to the Tomcat. Ideally, I should be copying it to the web apps, but this is where web apps will be available. And then we are exposing our port number, and we are starting our Tomcat. So now let's go ahead and build this image, the third version of our image. So this will be version 3 and Dockerfile 3. And this will start building the third version of our image. And this will be much more lighter in size and will be much more optimized. And let's wait for this to complete. Okay, so that's completed, and let's list our images. And you will see here there is my version 3, which is only 466 MB in size. So the first version, it was 847 MB, the second version is 630 MB, and the final version we have is 466 MB. And finally, we have made our container image secured and hardened, which is ready to use in the production, and also it is optimized, and we have a smaller version of the container image. So this is basically how we can containerize our applications, and you can follow some of these best practices to optimize your container images, reduce the size of the container images. That's all I have for this session. So we have looked at how you can create your custom images using Dockerfile. We also looked at how we can reduce the size of the container images. I will be pushing this code to my GitHub repo, and I will post the link to the GitHub repo in the description section. So you can, if you want, you can refer it from there. If you found this video helpful, then please leave a thumbs up, subscribe to the channel, and share with your friends. Thank you for watching, and I will see you in the next video.